Okay, in this video we're gonna continue learning Go. So last time we set up code server. I did some customization on the Termux. So as you can see, I removed the soft keys at the bottom of the Termux. You can change it by going to Termux and I believe Termux property. Wait a minute. Okay, it has something we can change, some file. Okay, it has like Termux properties. So this is where you can change it. Okay, this doesn't hide it. This this only hides the your full keyboard, Google Keyboard, Gboard, or whatever. I think that's something this is hiding. That's the thing that it's hiding, not the terminal soft keys. There are some settings here that's already commented out. You can turn it on if you want to. Here I can set, I have uncommented that says full screen to true. You can probably go to the documentation or whatever. They have the documentation, I think. Wiki Termux, Wiki terminal settings. See what each of these properties mean. Anyway, I removed all the extra keys, right? I set the extra keys to an empty array. That removed it. That's pretty much it. After you're done editing, just follow the instruction, press Ctrl X to exit. That's pretty much it. I mean, if it asks you to save it, press Y and press enter. Okay, to log into Proot distro that we installed previously, if you followed my video, you can use Proot distro, press the tab to autocomplete, use login, and whatever distro you installed. I installed Ubuntu, so it's gonna install the Ubuntu. But last time we also set up an alias for code that will launch code server, but we can't use it. It's because the profile isn't loaded in this shell for some reason. So you have to load it. Now we can use the code alias. Control C to stop the process. There are some Termux shortcuts you need to be familiar with if you want to use the Termux. Also, last time we struggled to copy paste stuff, right? As it turns out, you need to use Control Alt C and V, not Control C, not Control V, also not Control Shift C, Control Shift V. So you have to use the Control Alt C and Control Alt V. Let me show you. Okay, let's copy something. I can just copy. Control C works outside of the terminal, so I just use the Control C. Now, if I want to paste it, I need to use Control Alt V. There we go. That's pretty easy. That's pretty. If you're used to Control Shift V and Control Shift C, it's not obvious, right? You're like, oh, nope, it's not working. And then, yeah, you can use the Control Alt C to copy. Okay, that's just, I don't know, it kind of exited the shell. We need to run this source code. Okay, let's just launch the code editor, code server. one thing I noticed is that when I try to uh, delete using like select something, and then I try to delete it using the backspace, it's weird. Like it just, it just uh, crashes it, or like, although here it crashes, but if you have like um, only some few lines of code and try to select and delete it, it kind of like pastes garbages, like some text. Let me show you. So I'll just remove main go and create it again. So we have an empty file, right? So let's say I have something like this. I don't know what's going on, but when I press back, okay, that's weird. Let's do that again. Okay, that is weird. Okay, now, bruh. Well, it seems like I can't reproduce it, but when you try to press backspace, when you select some text, it just pastes garbage, right? And it crashes the code server. This only happens in Chrome. It might also happen in Firefox or some other browser. I haven't been able to replicate it, but when it happens, the other alternative is to cut, like use the Control X to cut instead of deleting it, and then just continue writing normally. Although when you cut, I think it's copies to clipboard, whatever, it doesn't matter. Okay, I do kind of feel like these sometimes, yeah, these buttons sometimes they don't like work, and like they kind of act weird. I don't know if it's the Chrome or any other browser. So I'm gonna just use the Firefox. I uninstalled and reinstalled. It went back to its default settings, and now we can go full screen on this. Just press OK. Now this is weird. Okay, there we go. We went full screen. Okay, let's go back to learning Go. So we were looking at tour of Go. So the only thing we didn't cover is concurrency. All right, let's go to Go routines. So concurrency is the hardest part in any programming language. It's kind of hard to wrap your head around. So let me ask ChatGPT to what is concurrency, and let's see what it spits out. What's Concurrency. Explain briefly. Using Go as context. Let's wait. In Go, concurrency means structuring a program so multiple tasks can make progress independently. It does not necessarily mean they run at the exact same time. That's called parallelism. Go's main concurrency tool is the Go routine. You'll see how to use Go routines in a bit. So notice how they're using the Go keyword and a function, right? They're just calling a function. Here all three tasks are started independently. Okay. The Go runtime decides where each Go routine gets CPU time. Think of it like this: sequential, download file, send email, process data. Only one thing happens at a time. Concurrent. Download file, send email, process data. So the progress is interleaved. Interleaved means like imagine like a straight line, or like imagine like tasks, right? Download file happens, maybe it progresses a bit, and then send email happens. After that, process data happens. Process data happens after that. Like they progress a little bit, right? Well, you need to like, this makes sense if you have heard about state machine, right? So a state machine can represent a task's state. Although I don't think we haven't come across how Go routine might use state machine. I think that's the only explanation that can explain progress is interleaved. So a task can be represented as a state machine. Like that's why they kind of make up like half partial progress, right? Anyway, so this, for a beginner, this sentence is kind of very weird. Like, what the hell is interleaved, right? There's runtime switches between tasks, so they all move forward. You don't even know how, like how the switches even happen. Like you only know, how can you switch when there's a download file task? How can you even switch? You can't just pass it, right? How can you pass send email? It's one full task. Maybe they are using state machine under the hood. I don't know. Concurrency versus parallelism. Okay, so we got CPU core 1. So this is how like interleaving works, right? Imagine we got task A, task B, A, C. Like we got only one core, but all the tasks are just using the one core, but they're just switching between just rapidly interleaving it. So this is what interleaving looks like. Only task A is not being executed. B gets a chance, C gets a chance, they all get a chance. One core rapidly switches between tasks. Parallelism, on the other hand, is just one task just gets hold of one core. Like task A is running on core, task B is running on second core, C is running on the third core. Tasks literally run at the same time on different cores. In Go, when you write, Go So we got function, and notice how they're using this what's it, parenthesis. This is just an anonymous function. Also notice it does not have a name, and they're just executing it. They declare it and execute it at the same time. You're creating a Go routine, which is a lightweight concurrent task managed by Go runtime. Like the reason the Go calls the Go routines lightweight is because like you usually this is coming from me um, using my Kotlin knowledge. So lightweight in this case means they are like, it's easy to explain coroutines as threads, right? Imagine threads, but imagine coroutines as thread, but they're lightweight. A thread as like stack, heap, other bullshit, um, things that makes it take so much memory. But coroutines on the other hand, you can have so many like coroutines running at the same time, and they take so little memory, but they're not the actual threads. It's like coroutines are just tasks that get executed on cores, executed by on core eventually. You might want to read about coroutines to understand it. It's kind of really hard. Coroutines usually communicate through channels. So this is how you create a channel. So it's let's not worry about channels for now. We'll get to it. So when we are like learning concurrency, it's easy to write a lot of code where we have deadlock, race condition. This kind of stuff is really easy to write, and when you use channels, you can avoid most of these pitfalls, right? Writing deadlock free code is kind of hard, but when you use channels, it's pretty easy. So that's why Go advocates for channels. So do not communicate by sharing memory, instead share memory by communicating. You might want to look into what the hell is deadlock, what the hell is race condition, stuff like this. I'm just gonna assume you know it. All right. Okay, now they're saying Go routine is a lightweight thread. Usually, like languages like Go routines, they try to uh, use an analogy, right? They're like, Go routines, it's just like a thread, but it's just lightweight, bruh. So they're kind of using the same analogy or whatever stuff you already know to explain it. Managed by the Go runtime. So you use the Go keyword and followed by a function. Starts a new Go routine running. This function, the evaluation of f, x, y, z, and z happens in the current Go routine, and the execution of f happens in the new Go routine. Go routines run in the same address space, so access to shared memory must be synchronized. The sync package provides useful primitives, although you won't need them much in Go as there are other primitives. All right, let's see what they're doing here. Okay, we got a function that's name is say. It takes a string and It's looping over 5 times and it's sleeping for 100 millisecond and then just printing S. And then we launch that function in a Go routine. So this evaluation happens in the current thread or whatever. Looks like this whole thing is executed on a so-called Go routine, and then this function executes in a new Go routine. In Kotlin, I'm just using Kotlin because I know Kotlin and it has something like Go routines. They call it coroutines. They also have channels, but it's much more elegant and it provides you so many like bells and whistles out of the box. Go on the other end, just figure things out yourself, bruh. They give you a lot of primitives, so you can if you can literally write your own library out of Go. So this is running, so essentially this function runs on a, you can imagine like it's running on some other thread. So you could say this runs on one Go routine and this function runs on another Go routine. So if this main function Go routine blocks, this other Go routine can still be executing. Okay, let's try that. So yeah, it just takes a string and doesn't return anything. But after some time, 100 millisecond to be exact, it sleeps and it prints whatever string value you provide. So this is the function we want, this is the code or task we want to execute in another Go routine. Although here they are like they are pretty much like executing this lines of code 5 times, right? Okay, we can use the modern or syntax for the for loop. The IDE keeps bugging me to use this goofy syntax. I guess if we don't want to use the I, we can probably delete that, I guess. Alright, now let's just run it. Use the go keyword and the function name, and also provide some string. And then just run it. Okay, what's going on here? It didn't run. Why didn't it print? Because main exists immediately. When main returns, the entire program terminates, and Go doesn't wait for coroutines to finish. Your program does this. Go, say hello from coroutine, starts coroutine, main exits immediately. So this is like asynchronous code. It does not wait for this function to complete. So that's basically asynchronous code thingy. Main starts coroutine, main ends, program exits, coroutine gets killed. To see the output, keep main alive long enough. A better Go solution. So here they're just keeping the main Go routine alive by sleeping it, bruh. Using the sleeping for 1 second. A better Go solution is using sync wait group. Okay, another approach is using wait group. Okay, this is not as complicated as you think. It's just you need to get the wait group and add 1. You just add 1. You pass 1. And then after this function block is done, you just call done method, which so it's like a counter. When you add 1, it just increases the counter, and when you call done, it decreases the counter. The wait method waits until the counter is 0. Also notice the defer, it runs after the block. It's like defer statements are read executed from bottom up. So if I add another defer statement on top of the done, it gets executed second, because defer statements executes from bottom up. Okay, so we're gonna use the wait group. It's not complicated, just it's a very weird thing. You might have not even seen it in other programming languages. So just get a wait group, bruh. Uses sync, like sync package. Okay, it's not, says it's not, and what the hell is that? So it's a type. It's what is this? Is this a type or something? I don't know how. So we created a wait group. Where do we add? Where do you add the counter? So we can access the wait group value here, because the value is in the scope or something. So we need to grab the wait group somehow. Okay, let's just call a wait add. 1, and then defer weight group, done. And now it just says undefined weight group. So let me also grab a weight group, and then pass the weight group. And then we need to call weight. Oops. So we got some, what is this? Say passes lock by value, sync weight group contains sync no copy. We'll ask ChatGPT for answer like why are we getting this squiggly line? See if it even works. Come on, right? So we got some error. Algorithms are asleep. Okay. So we got a fatal exception. What's wrong? You're passing the weight group by value which copies it, creates a copy of weight group, then calls done on the copy, not the original weight group that main is waiting on. Result, main's weight group counter 1, Gorotin's copied weight group counter also 1 for some reason. Gorotin calls done, copied counter becomes 0, main still sees counter 1, waits forever, fix it by passing a pointer. Okay, we need to pass it by address or something, pointer. We need to use the pointer. So let's wait for this garbage to work. So the type is a pointer and the value is the address, and this should fix it. Man, okay, there we go, it works. Also, let's just decrease the font for the terminal. Okay, what is this? This is the wrong place. Font size on the editor. Chat. Okay, integrated terminal. Cool. Let's use 14 on here. Nice. So we need to we had to do some bullshit to get this working, because the main Goroutine is just exited early before this Goroutine could finish. I mean, if we okay, they did use the sleep, so I was like, if they didn't use sleep, maybe this Goroutine, you know, completed its work and everything worked fine, I guess. But yeah, we need to use the wait group to wait for this Goroutine to finish, and you need to use the add or something to start a counter. Very complicated stuff. I mean, it's not that complicated. I don't like the fact that this refreshes every time. Okay, now let's look at channels. Channels are a typed conduit through which you can send and receive values with the channel operator. So this the channel operator kind of looks like an arrow. This syntax is very weird. They're not using methods, they're just using arrows, bruh. Like, probably in other programming languages, they got emit, send, receive. They got these methods, but here they're just using arrows, man. Very weird. So we got a variable and then arrow and v. So imagine for a moment that this is a channel, a type of channel, and this is a value. So send v to channel ch. The direction of the arrow kind of indicates whether we are sending values to the channel or receiving value from the channel. So right here, this we got, there is arrow coming out of the channel, so that means we are getting value from the channel, and here we are like pushing the value to the channel. The data flows in the direction of the arrow. Like maps and slices, channels must be created before use. So you need to use this syntax. You need to use the make and pass, the type channel int. This channel was integer values basically. By default, sends and receives block until the other side is ready. So this blocking mechanism might be new if you're coming from a programming language that does not have channel. So blocking means the code after whatever the sending or receiving method call or whatever happens, if it blocks, the next lines don't execute basically. So let's say this is the line, right? Everything after this line is kind of doesn't get executed when it's blocked. This allows coroutines to synchronize without explicit locks or condition values. Don't know what that means. The example code sums the numbers in a slice, distributing the work between two coroutines. Once both coroutines have completed their computation, it calculates the final result. Okay, so we got a sum function that takes a slice of integers and a channel, and they got a counter for sum, and then they range over the integer array basically, and they individually add the values in the array, and then they push the result to the channel. So we got the integer array, we create a channel, and we get, so look at this syntax. This is a very weird syntax, right? So essentially this takes a slice of the array. So it gets from 0 index all the way up to This takes the index value, so it takes the length and divides it by 2, which means we get half of the length. So if the length is 10, we get 5 or something. So 0 to 5, so that gives you the slice. So basically like around like these 3 values, and they take in the channel. So we're just starting 2 coroutines, and this gets the rest of the elements in the array or whatever. And then they are just calling the receive, like they're receiving value from the channels. So yeah, they are like assigning the values to 2 variables. You might want to look into how to assign values, how to get values. This kind of doesn't make any sense, right? This doesn't like make any sense, this value, like how? Very weird looking syntax. You would like assume like, I got channel, why the hell do I need this? Why can't I just use the C, bruh? So that's how you kind of like get the value from the channel. Okay, let's try to recreate that. I'm glad it didn't reload it. So what are we trying to do? So we're trying to create a channel where we get the sum of integers basically, and then we read that value, right? So we take an array of numbers, we split the array in the middle, and we pass the slice of array to 2 coroutines, and they calculate the sum of the elements of the array, and we get the sum, and later we combine it. So 2 coroutines does the task simultaneously, much faster, instead of just doing it in one coroutine. So let's create the channel. So you need to use the make and use chan and what value it holds. So we got the channel. We need the integer array or whatever. So I'm gonna just copy that. It's not really interesting part of the logic. It's just some static bullshit values. So this is how we create the slice of array. Slice. They call it slice. Bruh. Like, okay. Now let's create the function. Call this sum, and this takes let's say s for slice, and int, and ch for channel, int. It doesn't return anything. So we loop over for, we range over the element s. Since it's an array, we get index and value. So we don't want to use the index. We get the value. Also, we need a sum counter. So sum is initially 0. And then we use the what operator is that? I don't know, dude. Like we use the this operator like plus equal to plus equal sign v. So after we are done with that, we send the value to the channel. Okay, now we need to split and start two coroutines. Sum. Okay, we get the slice, and from 0 to length of s divided by 2, and then the channel, same thing, go sum s from length of s, so this is basically the half, all the way to the last, and then pass the channel. And now let's receive the values from the channel. So we need to use this syntax. Let's just print the values x, y. So I'm assuming, right? We still need the weight group, but let's see what happens. Okay, that's why I stopped using Firefox because the terminal is not opening. We have to use this goofy, start another new terminal. All right. Sometimes works, sometimes doesn't work. So this is the sum. Although obviously you can use the weight group, but for some reason we were able to execute just fine even without the weight group. So I'm going to ask ChatGPT why were we able to execute even without weight group? Because the channel itself is synchronizing the coroutines. When you do, main cannot continue until it receives two values from the channel. Until it receives two values from the channel, your coroutine eventually does pushes value. Since channel is an unbuffered channel, sending and receiving must meet each other. So main is executing and it comes across this line. It blocks the coroutine, it's waiting. Coroutine pushes some values, unblocks main, got first value, so it blocks the main coroutine and unblocks main, got second value, prints and exits. So main, last time it was able to complete, main was able to complete, so it exited. But this time, because we are waiting for the receiving from the channel, it blocked the main coroutine. So the channel acted like a mini wait mechanism. So compare that to your earlier example. So we got a function that prints some stuff. There was no channel receive. So main starts, coroutine starts, main exits, program dies. Nothing forced main to wait. So that's the only difference. Last time we didn't use channel, but this time we're using channel. We'll continue later.